Hello, and welcome back to Arduino Online. So this week, we're going to be learning about the analog read and analog write interfaces, as well as how to use the multimeter, and also the potentiometer. Seems like a lot to cover, right? So let's jump into it. But not like actual jump, it's like more of a metaphorical jump. It just means that we want to go into it, but like not actually jumping, it just means I want to go over to the next part. Okay, let's go. Here, I'm going to modify the previous circuit we had by removing the button circuit. Okay. But we'll leave the LED at the top here. But we'll be rewiring this from pin 8 over to pin 5, as pin 5 is an analog output pin, as you can see by the squiggly line over here. Now let's use analog write to create an LED that gets brighter gradually, then dimmer. To do this, we're going to be needing a for loop. The for loop has 4 parts: the initialization, the condition, the iteration, and the code block. The initialization is used to declare any variables at the start, when you first enter the loop. In this case, we are declaring a variable I starting at 0. The condition is used to declare what needs to be true for the loop to keep continuing. In this case, we are setting that the loop will keep continuing as long as I is less than or equal to 255. The iteration is what you execute at the end of each loop. And so at the end of each loop, we'll be adding 1 to the value. I++ is just shorthand for adding 1 to that specific variable. In this case, we are adding 1 to I. And then inside the code block, you write what you want to execute. In this case, we are writing the value of I to pin number 5. Oh no, someone's already coded it for me. You, however, probably didn't get your golden opportunity stolen from you. So pause the video and get some practice coding this out. Once you're done, just run the circuit. And the bulb glows. Great! Being able to watch it glow is nice, but what if we wanted a more concrete way to measure what's going on here? Let's take this opportunity to learn to use the multimeter. To get a multimeter, go to the side panel, just scroll down until you see multimeter, and just pull it out. Okay. So as you can see over here, the multimeter has 3 modes: current, voltage, and resistance. Let's try out current first. In order to measure something's current, we'll need to connect it in series with the circuit. And so over here, we're going to be disconnecting this wire and making this connection using the multimeter. Pay attention to where I'm connecting my negative end and my positive end. And now let's start simulation. And we should see that we get negative current. Well, in this case, negative current just means that it's flowing in the opposite direction of how we had connected our wires. In this case, we connected it in the wrong direction, meaning that we should have connected the negative over here and the positive over here. And so to fix that, you just need to swap where the wires are. Or maybe, if you like reading negative values, this is fine too. And okay. So now we get a reading of the current, and we can see that the pin is obviously outputting the current in increasing fashion, and then in decreasing fashion. Okay. Now let's try out voltage. In order to measure voltage using a multimeter, you need to connect your multimeter in parallel with the component that you're trying to measure. So let's connect the negative end to this side, and we want to know the drop across the LED. And let's switch our mode over to voltage. And now when we start the simulation, we should see that the voltage goes up gradually and then it goes down. Okay. We can also test the resistance here by clicking resistance, and we should get some error. This error here is caused by the resistance being too high and not being something that the multimeter can read. But as you can see, when it becomes in range of the multimeter, it suddenly becomes okay. And so we shall see more of this later when we try out the potentiometer. The potentiometer is actually a really simple device. All that the potentiometer does is it quote-unquote cuts the voltage into two parts. We can demonstrate this here using two multimeters, one connected from the ground over to the output, and one connected from the 5 volt over to the output. And we should see that this potentiometer serves as a sort of divider of the voltages. If you guys have studied Form 4 or Form 5 physics, you guys should remember how to be able to divide a voltage. And that's with both sides having different resistance. So in this case, that is abstracted from you, and this is done by the potentiometer itself. So as you can see, the top voltage and the bottom voltage always add up to 5 volts. All that is happening is you're deciding if you should drop more on the top side or if you should drop more on the bottom side. Okay, now that we understand what the potentiometer does, let's see how we can read this value into our microcontroller. To do this, we will be needing the analog read method. The analog read method takes in a pin and outputs the analog reading at that pin. To display our readings, we are going to be using the serial objects print line method to print to the serial interface. This method simply takes what you wish to print as the parameter. ArduinOnline is the Arduino cooking show, and so the code here has already been magically done for me. But don't worry, I'll take you through it so you know what happened in the past 20 minutes that the cake was baking. So over here in the setup, we are setting the pin A5 to be the input. Remember that if you want to read analog, you have to connect to a pin that is labeled analog in. If you're using the Maker Uno, however, you can connect it to any of the pins that have the squiggly line, because any pin that can output in analog can also read in analog for the Maker Uno. But this is not true for the original Arduino Uno specification. Line 4 over here sets the sampling rate of the serial interface. Don't worry too much about it. This 9600 will be correct for you for 98.765% of the time. So just put 9600. But for those of you who are wondering what this is the sampling rate, and so you're telling the serial interface that it should update itself 9600 times per second. Inside the loop over here, we're just taking analog read from A5, so we're reading the value, and then we're printing it out onto the serial interface. We also have a delay over here of 100 milliseconds, so that it doesn't spam us too much. Now we can start the simulation. Okay, and pull up our serial interface, and we should see that right now it reads 552. As we alter the dial, the reading should change. With it, if we put it all the way up here, we should get a reading of 0, and if we put it all the way down, we should get the maximum reading of 1023. And in between them is all the values in between. And as you can see, the writing values, the maximum that we can write is 255, but the maximum that you can read using the interface is 1023. As for why there's such a big difference, I don't know, and if any of you know, please put them down in the comments, because I am just as confused as you are as to why writing has a maximum of 255, while reading has a maximum of 1023. It's like for some reason, if you write, you can only write in 8 bits, but when you read, you can read in 10 bits, which doesn't make too much sense to me. But oh well, it's what they implemented. And that's it! Today we learned how to use analog read and analog write to read values from 0 to 255 and write values from 0 to 1023. Now that we have the basics out of the way, in the next video we can take a look at using more interesting components like motors, ultrasonic sensors, and the buzzer. See you in the next one!